So this is a inverse hyperbolic function. So if you remember, it's just switching the x and the y's to make our inverses, and that these functions need to be one-to-one to have an inverse. So the inputs become the outputs become the inputs, and so on. So what we're going to do is show that the inverse of our hyperbolic function, cosine, is this. So what we're going to do first is rewrite it, and we're going to switch the letters. So x equals e to the y plus e to the negative y over 2, and we're going to solve for e to the y. It's a little too quick. Come on, catch up. There we go. So e to the y plus e to the negative y. And what we're going to do now is multiply everything by e to the y. That will get rid of that negative exponent. So we're going to multiply this side by e to the y and this side by e to the y. So we end up with 2x times e to the y. You'll see why I'm doing it that way. E to the 2y, because this is going to be multiplied, so y plus y. And then that one comes out to be 1, because they cancel or they add up to make 0 for your exponent, however you want to look at it. So we're dealing with here now with e to the y is actually a quadratic. So we're going to move everything over to the right side. So it looks like this. So now if we substitute u for e to the y, we get this. Okay, so now if you take and look at it, we see a is 1, b is negative 2x, and c is equal to 1. It's our quadratic. And so we say that e to the y, which is our u, is equal to, and we do our normal quadratic formula, which is negative b, so 2x plus or minus the square root of b squared minus 4ac all over 2a. And then if we simplify this, you'll get 2x plus or minus the square root of 4x minus 4 over 2, and then there's a square in there. You can see the excitement that that's factorable, so you end up with 2x plus or minus, and if we factor out the 4, it becomes a square root of 4, which is 2. And then the 2's cancel, and we get x plus or minus square root of x squared minus. And then now we solve for y, so we go e to the y equals x plus or minus the square root squared minus 1. So y equals the natural log of this. And so if you look at our cosine, our hyperbolic cosine, you can see that we have to actually cut it. It's not one-to-one. Our horizontal line test fails. So what we do is we cut it here. And so if we write that, we know that x is greater than or equal to 0, which means y is greater than or equal to 1. And so if we switch those down here, you can see that x is greater than or equal to 1, and y is greater than or equal to 0. So that's where our x is greater than or equal to 1 comes into play. All right, and so now we can also get rid of the minus and put a plus, because if you leave it that way, it's going to be a very small, you're talking about the square root, it's a smaller one. So if you subtract these two, these are going to be fractions, which makes your natural log negative, and we need to have our y greater than or equal to 0. So we don't want to have very, very small less than 1 fractions here, because they're going to give us a negative exponent, and that won't work. So it's just the plus, and so there you have it. All right, so let's try some. So if we have inverse cosh of 1, then we're going to take our hyperbolic inverse of cosine and plug it in. So this would become natural log 1 plus the square root. And so this would end up giving us just the natural log of 1, which is 0. And if you remember, we can plug these into our calculator. So you want to go to your catalog. So second catalog. And then this is C. So remember, it's A, B, C, and it'll take us to C. And then you just scroll down until you see it. So you got to go all the way to O. There we go. And there's our hyperbolic cosh, but we want the inverse. So one more, and there it is. And then you plug in 1, hit enter, and it says 0. So it's very quick to check. Maybe you still have to show work, though. All right, what about hyperbolic sine? So same thing. We're just going to plug it in so you can see it up here. Natural log of -1 plus -1 squared plus 1. So this would equal to the natural log of -1 plus, and then square root of 2. All right, now to make sure this is correct, there we have it. That's our decimal. And so if we go now into our catalog, S is right here. You can see there's S. And then we scroll down until we see the inverse. Right there. And then we plug in -1, hit enter, and you can see it's the same. So that is correct. All right. Now let's look at some tangent and cotangent. So you want to always know with your inverses what your inputs and outputs are. So with tangent, we know that our domain is -infinity, +infinity. You can see that we can plug any x value we want in all the way across, but the range goes from -1 to 1. So that means for our inverse tangent, the domain, as you can see, is from -1 to 1, but the range would be infinity, infinity. So what that means is we can only plug numbers into our inverse tangent, hyperbolic tangent, that are between -1 and 1. So 0.5 works. So let's see what we get. So it's 1/2 natural log of 1 plus x over 1 minus x. So 1/2 natural log of 1 plus 0.5 and 1 minus 0.5. So this would equal to 1/2, and then that's 1.5 over 0.5, which is 1/2 ln of 3, and you could even put that half in and say ln of square root of 3. Or 1/2 of ln of 3, and now we just have to check it. So we're going for 5.49, so second catalog, and then we got to find t, that's number 4, and there it is, inverse of our tangent, and then we're going to plug in 0.5. And there it is, 0.549, so it checks perfectly. All right, so now let's try our inverse cotangent. So again, you want to think about the way this works. So our hyperbolic tangent is the reciprocal of the hyperbolic cotangent. That's not the inverse here. So whatever we plug in here will give us this number. So this 2 is really this value right here that we're sitting there. So you got to think about it this way. It's really this for our hyperbolic tangent. So if we convert this into an inverse, we end up with this. Oops, let me change that back to an x just so we have it. So they just get switched here. So really, having a 2 in here for a cotangent, if you just flip it, it tells you what it is for the other one. So this is really just the hyperbolic function of 0.5, which we already know to be ln of rad 3. You're not going to run into any of these. We're dealing with just plain old base 3 ones that we are going to deal with, but just so that you have it, there you go. So if you want to know more about that one, even though you don't have to cover it, you can keep continuing. So if you look at your cotangent, your domain here is from -infinity to 0, union 0 to infinity. And the range, looking at the picture, is from -infinity to -1, union 1 to infinity. So for our inverse, its domain would be -infinity to -1, union 1 to infinity, and range would be from -infinity to 0, union 0 to infinity, which makes complete sense, because if you think about it, these right here are our outputs. So if you plug in an x, you get that number. So that's our inputs here, the numbers that we plug in here. So the numbers we plug in here are what we're flipping. So if you think about it, if we flip a half, you would get 2. So you can see it's going that way. And then if we flip a third, we get 3. And if we flip a fourth, we get 4. And so working our way in towards 0, we're working our way out this way. And then the negatives work the same way. So we're just flipping them. So -1/2 would be -2. And you're working your way in, which works your way out for the cotangent. So all you have to do is think of, okay, well, that was my output. That's the ratio that I flip. So I flip it, and that's my tangent.